All right, Unit 3, Section 5.2. This is friction. Yes, I'm recording this now.
Hi.
Because
Hi, people of YouTube, and hi, people, I mean the 3 people that might watch this.
I watched it when I was absent.
So, this is Unit 3, Section 5.2. My mom won't watch YouTube. I don't think she ever has. All right, so Unit 3, Section 5.2. We're going to be talking about friction today. We're going to be getting started on friction. Now, this is the last, I guess, topic in this unit.
Yay!
Right? So,
No, that means test. Don't say
we're
it.
going to test you. Okay. Now, we're going to talk about air resistance today, and basically all of your air resistance will come today, and then we'll talk about friction a bit next week. All right. So, actually, I think we'll start tomorrow.
We can watch that
So,
video again.
friction. Friction. What is friction?
A force that acts on something.
A force that acts on something. Wonderful.
And a force that is exerted in the opposite way the object moves.
So, does there have to be 2 objects or just 1? Has to be 2?
Well, no. I mean, because it could be the ground and.
Opposing force.
Infinite
Okay.
God.
It's an opposing force. You guys are on the right track. So, Jose said something that opposes the velocity, or in the opposite direction of the velocity, right? Not said an opposing force. All right.
To motion, acceleration.
Doesn't
Okay.
slow down.
So that sounds a little bit like inertia, doesn't it? Right? But inertia resists a change in motion, right? Right? Okay. Inertia resists a change in motion, right? That was Kyle, if anybody heard that. What does friction do? Okay, Rex says, guys, friction slows things down.
Well, it makes it accelerate.
Okay. I would say that Rex and Jose and Nan, but not Kyle, okay, are all correct. Okay, friction
Tries to restrict motion.
Friction is a force that opposes
What's the why to you, Reggie?
motion.
He doesn't like this
I want
class.
to see
Okay.
you. You're in this area.
Friction is a force that opposes motion. Typically, it will decrease velocity. Okay. Now, Kyle says, isn't that when something rubs against something? And that is true, Kyle. A lot of times, you guys might be outside. Let's say it's Friday morning, Thursday night, whatever it is. You guys are out waiting in line to get to the store of your choice. All right. Your hands might be a little cold, so what are you gonna do?
You rub them together.
Right?
You rub your hands together. Now, as you rub your hands together, you are forcing your hands together, right?
Yeah.
The friction acting between your hands is heating up your hands. Okay? More often than not, whenever friction is acting on something, the energy lost by the object turns into heat. And that's why this warms your hands up. The frictional force is causing your hands to lose kinetic energy. That loss in kinetic energy turns into thermal energy, which warms your hands up. Sometimes it's beneficial, sometimes it's not. But that is a use of friction. All right. In our class, we're going to be talking about objects that experience friction. Nope. This is the only physics class. This is your only option. Or you go to the first term, the same thing. All right. So let's say I have an object. We'll have it be like my projector remote. Okay. If I slide my projector remote across the table, it moves with a certain velocity, right? What's happening at velocity the whole time it's moving across the table? It's decreasing. It's slowing down, right? So if I push, let's say this is my remote. If I push on my remote this way, right? For the moment my hand's on the remote, it feels a force which causes it to accelerate in that direction, right? Once I remove my hand, what happens to the object? It slows down, right? The object has a velocity in this direction.
The acceleration.
Right? Good. But it accelerates in that direction, which causes this velocity to decrease. Since the acceleration is that direction, which way is the force? Okay. Then that force acting on the object has to be this way, and that force is friction. Okay. Now friction, and I forgot to write this earlier, but friction has a couple letters. You might see F, script F non. Okay. You might also see F mu K or F mu S. Okay. Mu is the coefficient of friction. All right, we'll get into this later. Mu is a Greek letter. Mu S means static friction, and mu K means kinetic friction. And those are different types of friction. Could also see F mu rolling, F mu air resistance. You could also see FAR, I mean, there's lots. You can see F, drag. There's lots of different ways they denote friction. Now, is a block sliding across a table? Is that the only type of friction?
Nah.
Well, this is sliding friction or kinetic friction. That's one type of friction. Another type of friction is stationary friction. If you don't believe me, what I want you to do, if you're sitting in a chair, not a desk, put your feet on the floor, and if you're in a desk, it works too, and push back a little bit. Now, is there a time where you apply a force and you don't move? Try to push so you don't move. Okay? Try to push on the floor so that you're not moving. Right?
Your feet like this.
Okay? Like push one way on the floor. Like try to push yourself back, but I want you to push with such a force that you're not moving.
All right, I'm not moving.
Okay?
I'm not moving.
So when you're not moving, that's because there's a frictional force acting on you that's keeping you stationary, right? If you're sitting in your chair and you're pushing back, so I'm pushing, so I want to go that way, right? Right? I want to push myself that way. Which way is friction act? The other way. It's preventing my motion. Then once I push hard enough, then the wheel slide, won't we?
Yes.
Okay. When your force is hard enough, then you break what's called static friction. All right. So we're getting into some types of friction. One type I said was static. Is static for a moving or stationary object? Stationary. Static means not moving, means stationary. Okay. Like static stretches, it's where you just stretch and you hold that position for a 10 count, right? Right? Static stretching is just being stationary. Another type of friction is kinetic. What does kinetic mean? Moving. Okay. But usually in friction terms, kinetic really means sliding friction.
Like a choo-choo train?
No. A choo-choo train has rolling friction. But there is static friction between the wheels of the train and the track.
That's what another one is rolling friction.
Right. Another friction is rolling friction. Actually, I want to put rolling at 4.
So is that like
A choo-choo train, the wheels are experiencing rolling friction. Okay. Rolling is a combination of kinetic and static friction that is actually much less because the object is rolling. So each point, so I had to ask about the choo-choo train, right? Okay. So this is the wheel, right?
Yep.
Here's the track. This point right here, because the wheel is going this way and it's rotating around, right? That point right there experiences static friction. Well, the rest of the wheel continues to rotate. So once this wheel rotates far enough, this point is no longer in contact. Okay? If that static friction didn't occur, then this wheel wouldn't be going anywhere. Okay? This wheel would not have a velocity in that direction. All right. So if there wasn't static friction between the tire, or between the train wheel and the track, it wouldn't go anywhere. Same thing with your cars. All right. I just changed the tires on my car, right? Because the tread was all worn off. All right. With that worn off tread, when it rains, that static friction will not be great enough to keep my tire spinning. So my tire will not be great enough for my tire to keep traction. So my tire will spin and then I'll slide, right? Does that make sense?
Yeah.
So that's why you want to get tires that have good tread because it displaces water, so that way it keeps the car in contact with the road. Thank you, Ashley. So that's type of rolling friction, but rolling is really a combination of static friction going on. Rolling friction is the smallest friction. That's why we have wheels on our car versus triangles.
Oh.
The fourth type of friction, which actually going number 3 on the list, is air resistance.
Oh, yes. I forgot about that. Nobody really cares about it.
But instead of air resistance, I'm going to put fluid.
Why?
Because if I put air resistance, you guys only think it's going through air, right? Going through a gas. But it also acts on something going through any fluid, water.
What about solid?
Any substance, well, a solid is not a fluid. Any substance where the particles can move around is called a fluid. That includes gases, water, and plasmas. We won't worry so much about plasmas because it'll melt the objects we talk about.
Are you sure?
They're really high energy. All right. So gas and liquid is what I mean by fluid friction.
I didn't buy no plasma.
Now, these are listed, guys, in order of decreasing strength. So static is typically the strongest. Next is kinetic or sliding friction. Then is fluid. Then is rolling. Now that's typically. It's not always the case. All right. If something is passing through molasses, it probably experiences a lot more friction than if it's just sliding on the table. All right. But if something is passing through the air, it experiences a lot less friction than something sliding on the table. So this is just a typical order. It's not every case. All right, are there any questions? Okay. So, this block sliding across the surface, it experiences friction, right? Right? What about this tennis ball?
That's baseball.
This baseball.
Fluid.
Okay. What are the forces acting on the baseball right now?
Gravity.
If I'm holding the baseball, right?
Gravity.
There's gravity in my hand, right?
Yeah.
When I let go of the baseball, what's acting on it?
Gravity.
Gravity, right? There's the force gravity going down.
And air resistance. But we've been calling it force.
No, force normal is when something's supporting. So I held something underneath it, then I experience a force now. Okay? This would be the force of my hand pulling up, it might be a force pull. If I had a string, it'd be a tension. Okay? But once I let go of it, gravity's acting on it, right?
Yeah.
Now, all along we've just ignored air resistance. Because if I were to drop a ball from this height down to the floor, air resistance wouldn't play a big role. But if I were to drop this ball from the top of a very tall building, like let's say I'm on top of the Empire State Building, right? And I drop this ball, the air resistance will play a role. Okay. Now, some of you might be saying air resistance. How is there air resistance? Well, the air is made up of tiny little particles, right? Right? Now that's a lot more dense than it actually is. But as the ball falls through the air, it collides with those particles, don't they? Every time that ball collides with one of those particles, it exerts a force which way on the ball? Up. Okay. And if you don't believe me, the next time you are in your car driving down the highway, or in a car driving down the highway, ask permission first, I don't want you to hurt yourself, but roll the window down and stick your hand out the window. Okay? Where's your hand go? It goes back, right? Because your hand is now colliding with air particles, right? Which then force your hand back. Okay, one of the things that makes plane flies is if you take your hand and you hold it flat like this, nothing happens. If you angle your hand like this, what happens? Goes up, you create lift. Okay? One of the things that creates lift is partly Bernoulli's principle, but the other thing is the wing collides with air particles, which exert a force upward and push the plane up. So that's part of the way planes fly. Right? It's this whole idea of air resistance. So air resistance isn't quite a bad thing. Right? But which way does that force act? Up. Okay. So this is a frictional force. You might see, I like to write FAR to remind me it's air resistance. That's not far. Okay, it's just air resistance. You might also see force drag.
Right? You said force drag.
Force drag.
Oh, drag.
Like drag force. Okay. But this air resistance, guys, is a result of colliding with particles. Every fluid friction is a result of collisions with particles. Okay. Now, if these particles are more densely packed, like in water, what's going to happen to that frictional force, that fluid friction? It's going to go up, right? So as the fluid gets more and more dense, the force of fluid friction increases. Does that make sense?
Are we playing roller coaster marble?
We might.
Yes, that was so much fun.
Okay. Goodness.
That was an easy
Off topic already. All right. So air resistance. Air resistance specifically, guys, is the frictional force exerted on an object as it passes through air and collides with air particles. Right? So air resistance is the frictional force, not fictional, frictional force exerted on an object as it passes. Actually, I'm gonna take passes out. As it collides, I like that better, with air particles. They make you laugh?
How come our physics book isn't like the physical science book? 'Cause it was
With the
way
key
easier.
questions?
Yes, I totally
Because-
get those.
And it gave you the answers to all our homework.
Right. So
It
it
was
didn't
Easy
let
to
you.
understand.
Okay.
Yeah, it was way easier.
Just like the chemistry book is just like the physics book, but it's hard to understand because I don't like it.
Well, we're taking a step up.
Well, we shouldn't.
Okay. Don't push yourselves. Just consistently stay at the same level. Don't the whole thing you either get better or worse. Nope. We want to stay exactly the same.
But we're doing the same
Okay.
thing with lead.
All right. So air resistance is a frictional force exerted on an object as it collides with the air particles. We're going deeper though.
But does it even help if we took
How
physical
deep?
science?
How
Because
deep are we
we're
going?
already doing the same thing.
It helps you a little bit. You have a base understanding. All right. Just like working on getting me off topic, aren't you?
Yeah.
Oh.
All right.
I should have took geology.
So-
last time.
Here I have 2 pieces of paper, right? Right. If you don't believe me, I'll unfold this one.
I want to examine it.
Okay. These 2 pieces of paper are exactly identical in every way, or they were exactly identical in every way until I did what with this one? Crumple it. So 2 pieces of paper. One I'm going to crumple up. The other one is left flat like that. No, super strong. Just a mean guy right here, crumpling up paper. All right. Now, what do you know the force of gravity exerted on these 2 pieces of paper? The same. They have the same mass, so the same force of gravity, right? So when I drop them, should they have the same acceleration?
No.
They should.
They should.
But they're
If we could ignore air resistance, they would, right?
Yeah.
But in this room, can I ignore air resistance?
No.
No, because there's air particles which let you breathe. Okay. So if I drop these, right, the sheet that was not crinkled up falls much slower, right? Because it's feeling air resistance. Okay. That's one thing that affects air resistance. There are 2 factors that affect air resistance. Okay. One is what? Surface area. Another thing right here is cross-sectional area. Think about cross-sectional area, you think about a car. You might not think of a car as a rectangle, but if I were to take a car and completely compress it down, then it would look like a rectangle in the front. Okay. Or like if I look at a truck. A big truck has a big rectangular front. All right. Surface area, cross-sectional area is the same thing. That's how many particles an object collides with, right? So that does it have a direct or inverse relationship with air resistance? Direct, right? The uncrumpled piece of paper. The uncrumpled piece of paper fell slower, right? Because it experienced more air resistance. So surface area has a direct relationship. What's the other thing that affects air resistance? Now remember, air resistance is a result of collisions with air molecules, right? How can I increase the collisions with air molecules? How can I increase collisions with air molecules? Okay, we already did that. Surface area did that, right?
Wait, what's the question?
How can I increase an object's collision with air molecules?
Make it higher.
We already made it bigger, surface area.
Go higher.
Nope.
More acceleration.
More acceleration. You're getting there, right? Think about putting your hand on the window of your car. If you're going 5 miles an hour and you put your hand out, does it push your hand back for your hair? No. If you're going 25 miles an hour, does it push your hand back for your hair? A little bit more, right? If you're going 75, what happens?
It's like,
I'm ready.
Yeah, cow in the face. That's awesome. All right. It pulls your hand back, right? Because you're hitting more air molecules per second, right? Does that make sense? If I'm traveling faster, then my object collides with more air molecules per second. So I have to push the gas harder to stay at higher speeds.
Sure.
Right? Because your car needs to supply more energy, more force. All right? So the other factor that affects air resistance is speed. Okay. We can talk about density too, but we're just about air here. We're talking about any fluid, the density of the medium would affect it too. So surface area effects and speed effects
we're gonna need
air resistance. Now both of these have a direct relationship. So what that means is that as surface area increases, so does air resistance. Okay? And as speed increases, so does air resistance. Thank you. I tried to write it fast because you said you're getting into it. Now, the last topic we need to discuss today about air resistance is this thing called terminal velocity. Has anyone heard of terminal velocity before?
Yes, we took this class.
Okay, what is terminal velocity, Nan?
When air resistance is the same as gravity.
When air resistance equals gravity, right? So if I have an object that has gravity acting down, right, and air resistance acting up, it doesn't float. If these two are equal, that means the acceleration is 0. So, good. So terminal velocity is the point when an object reaches a constant velocity because the air resistance equals the force of gravity. I want to make sure I write down exactly the book has. I like the way they say it. So terminal velocity is the constant velocity of an object that is reached when the force of air resistance equals the force of gravity.
You just stepped on one of the pieces of paper.
I know. The constant velocity that is reached when the force of air resistance, Kyle,
It's a good question.
equals the force of gravity. Now you're probably saying, when does this occur? Okay, or how does that happen? How does air resistance equal gravity? Right? Well, when you initially drop something, it doesn't have a large speed, right? As that speed increases, what happens to air resistance? It increases. So when an object reaches terminal velocity, it is at a relatively high speed compared to the object's initial speed. Because as speed goes up, air resistance goes up. Yes, Kyle?
So when you put your hand out the car, is that terminal velocity?
Actually, when you put your hand on the car, if you're going at highway speeds, that is much greater than the terminal velocity, considering that your hand goes back. Now, terminal velocity usually works with gravity and air resistance. So you're thinking of maybe like the force forward of your shoulder and the air resistance. So if your hand goes back, that means air resistance is greater. So that'd be like a situation where the force of air resistance is a lot greater than the force of gravity.
Okay, so if your hand stays, then that means.
That'd be kind of like the terminal velocity between your shoulder and the air resistance. Good question. Okay. Now, do larger objects, when I say larger, I mean more massive, okay? Do objects with a higher mass have a larger or smaller terminal velocity? So do objects with a higher mass have larger or smaller terminal velocity? Here, some of you say larger, and some of you think you don't know for sure. Think about it this way.
It's a no.
Good. If I have a 1 kilogram object, and it was a force of gravity down that's equal to 9.8 newtons, right? Right? If I have a 10 kilogram object, it has a force down equal to, that's terrible, equal to 98 newtons. 10 times 9.8. Does that make sense? Now, if I drop both of these objects from a very tall building, as these objects increase their speed at 9.8 meters per second squared, they're both going to increase their air resistance, assuming they're the same cross-section area, the same surface area. They're both going to increase their air resistance at the same rate, right? Right? Now, this 1 kilogram object, it will reach a point where the air resistance equals 9.8 newtons up before the 10 kilogram object has an air resistance equal to 98. Okay? For example, if I take 2 golf balls, right? One's 1 kilogram, one's 10 kilograms. I know it's not very likely, but we'll just go with it. Okay? If I drop them both, right? They have the same area, so they're going to experience the same air resistance, right? The 1 kilogram one will reach a speed where its air resistance is 9.8 sooner than the 10 kilogram one will. Okay? The 10 kilogram one is not at terminal velocity until the air resistance is 98. I have like 30 seconds left, okay? Now, which one will have a higher velocity? The 10 kilogram one, because it has accelerated for a longer time because it takes longer for the air resistance equal 98 versus 9.8. So larger objects will have a larger terminal velocity because they accelerate for longer. All right? All right, nice job, guys.
We already learned this.
Have a good day. Don't forget your homework.
No, no.